Using three properties of logarithms, we're going to evaluate these three logs. Let's look at part A. You got log base 3 of 4 over 5. So what is that? Using quotient property, we could rewrite this as log of base 3 of 4 minus log of base 3 of 5. So using the given information over here, it's going to be 1.262 minus 1.465, which is negative 0.203. What about part B? Part B, you got log of base 3 of 20. You could rewrite this as log of base 3 of 5 times 4. And using the product property, this is the same thing as log of base 3 of 5 plus log of base 3 of 4. Using substitution, you get 1.465 plus 1.262, which is going to be 2.727. What about part C? You got log of base 3 of 25. Well, there's two ways you could do this. First way is you could write it as log of base 3 of 5 times 5. And you could use a product property. Or what you could do is you could write it as log of base 3 of 5 squared. And using the power property, that 2 comes in front of log, and which is 2 times 1.465, which will be 2.93. So you could have used the product property, or you could have used the power property, but you will get the same result. I want to talk about common errors that students make mistake when they use the properties of logarithms. Log of base b of m over n is log of base b of m minus log of base b of n. But a lot of times students think this is the same thing as log of base b of m over log of base b of n, which is incorrect. So be careful, this is not correct. Also, log of base b of m times n is log of base b of m plus log of base b of n. However, a lot of students put it as log of base b of m times log of base b of n. So be careful, this is also incorrect. Make sure you avoid these common errors. In this example, we need to expand this logarithmic expression. So first, using the quotient property, this is the same thing as the natural log of 3x to the 5th minus natural log of y. But we could still break down this using a product property. So natural log of 3 plus natural log of x to the 5th. Now using the power property, you can write it as 5 natural log of x minus natural log of y. So this is the expanded form. Now when we go back from here to this formula, we call that condensing. So now we need to condense this expression. So what we need to do is let's move the 4 using the power property. Let's put the 4 right there. And what's 3 to the 4th power? That's 81. Now, we could use these two as a product property, so that becomes log of 6 times 81 minus log of 3. Now, this is the, we could use the quotient property, so log of 6 times 81 over 3. You could simplify this. So it's going to be 6 divided by 3 is 2, and 2 times 81 is 162. So log of 162. Of course, the base is 10, but you could just say log of 162. Now we're going to talk about change of base formula. Let's say you have a log of base c of a. That will equal to log of base b of a over log of base b of c. So this means that let's say you have a log of c, base c of a. That is going to be equal to log of base 10 of a over log of base 10 of c. Or you could also say natural log of a over natural log of c. Because what is natural log? Natural log is log with base e. So as long as you have a same b over here, log b and log b, you could write it at, you could write this as log base b of a, log base b of c. So another example is, let's say you have a log base of 7 of 5. I mean, you could say log base 3 of 5 over log base 3 of 7. But when we change the base, we usually change the base with the base 10 or base e, which is a natural log, because this is not really useful when you have a base other than 10 or e. There are two ways of evaluating this. You could write base 10, so you could say that this is the same thing as log of base 10 of 11 over log of base 10 of 7, which is the same thing as natural log of 11 over natural log of 7. And both answers will be approximately 1.232. You could check with your calculator. Again, if you want to change the base, this is the same thing as log of 19 over log of 2, or natural log of 19 over natural log of 2. And both of them will approximately 4.248.